Let's take a look at number 4 in section 5.7. We are to write the integral in terms of u and du, of course, so find the du once we do our substitution, and then evaluate it. So pretty simple one. They actually give you the value of u, okay, which is x plus 1, which makes sense because there is a composition of two functions here, right? X plus 1 is inside the u to the 13th power function. Okay, so when I find my du, well, the derivative of x plus 1 is just 1, so du is equal to dx, right? Du over dx is equal to 1, so du is dx. Now, if I look up here, I'm going to have what? X plus 1 is u to the 13th power, okay? The dx will be du, so I have u to the 13th du, but what about this x? You can't have x's and u's mixed together, right? Well, since u is equal to x plus 1, I can solve for x by simply subtracting 1 from both sides. X is u minus 1. And that's what I'm going to replace x with, right? So I now will have the integral in terms of u and du. Integral of what? X is u minus 1. So just replace that. X plus 1 to the 13th is u to the 13th. And dx, right, is du. So here's how the integral is transformed. Now, before we integrate, what do we need to do to evaluate this? Well, I need to distribute, right? First, before I can find the antiderivative. You cannot find the antiderivative of u minus 1 and the antiderivative of u to the 13th and just multiply them together. That's not going to work. Think about taking derivatives. Is that the way we take derivatives in the other direction? No, we have a product rule, right? So it's not that easy. But if I distribute the u to the 13th, I get u to the 14th minus u to the 13th. Now I can take the antiderivative of each of these, right? Antiderivative of u to the 14th by the power rule. Add 1 to 14 is 1 u to the 15th divided by 15. So 1/15th u to 15th. And the antiderivative of u to the 13th is 1/14th u to the 14th. There's my antiderivative in terms of u. Don't forget u was x plus 1. So replacing u with x plus 1 gives us this final result here. Okay, hope that is helpful.